So we got our next topic, which is the mass of lamina. So as you can see, this is just a random shape, and we are looking for the mass of that shape. So we have here the rho, which is a function of x and y, and then the dA, which is a rectangular, which is dx dy equal to, or dy dx. So, and this will be your lamina, the random shape. So this is similar to a plate which is made of particles which even or uneven distribution over the region. So if the particles are evenly distributed, that will be your homogeneous, and if the particles are unevenly distributed, that will be non-homogeneous. Of course, the mass will just be area density times the area. Okay? Because the density must be mass over area. So multiplying it by area, you will cancel out the area. You'll be left with the mass. So of course, the unit will be kg or kilogram. So that's kg over square meter times square meter. So you'll be left with kg. And then the mass will also be the rho or the area density times the area. So you have two types here. Yeah, you can use either. So mass is equal to the double integral of x1 to x2, y2, y1 to y2, rho dy dx. Of course, the outer limits must be constants, and the inner limits must be in a function of the outer limits. So as in this case, the inner limit will be dy. Therefore, the dy must be a function, or the limits of dy must be a function of x. And the same with this one. All you have to do is just interchange those. So you'll have here x1 and x2 must be a function of this must be x. Okay, so there's a little typo. Okay, so let's try this one. Okay, so for number 1, we have a lamina with density xy. Okay, so therefore we have a density equal to xy is bounded by the x-axis and the line x equal to 8, and then we have another curve which is y is equal to x raised to 2/3. Okay, so find the mass. As you can see, the mass now will be equal to double integral. So the problem here is, which is it, dx dy or dy dx? So in this case, it's better to be dy dx because the you have here rho, right? Okay, rho. Because the y we have here, y is equal to x raised to 2/3. As you can see, y is already in terms of, or y is already a function of x. So you'll have here the limits in the inner limits must be a function of x. So you'll have here the upper limit for the dy will be x raised to 2/3 from 0. Okay, and then the limits for the outer limit or limits for x or dx will be 0 to 8. Okay, and then with this, all you have to do is just, this is 0 to 8, and then this is integral of 0 to x raised to 2/3, and then rho is xy, right? And then dy dx. So evaluating this, you have to start from the core or the innermost part. So you'll have here integral of 0 to 8. Integral of y will be, so copy x because x is just a constant. So x y squared over 2. Okay, this is limits from 0 to x raised to 2/3 dx. Okay, and then so integral of x raised to, so y squared, right? So you'll have here x over 2. So applying the limits, you'll have your x raised to 2/3, okay, squared minus 0 squared dx, and then forget the limits, which is 0 to 8. Now if you can now enter this in your calcu. Entering that in your calcu, you'll get a value of 153.6 kilograms. Okay. So that will be your final answer.